It's been 2 months since I started the restoration of this Onkyo M-510 amplifier. And this is the video where I plug it in and try it for the first time after my restoration. In between the last video and now, I serviced both amplifier boards. There wasn't much to go over that I haven't already covered in previous videos. I replaced the mica wafers with a thermal paper, and I also replaced the few electrolytic capacitors that are on those boards and tested everything to make sure there were no shorts. I wasn't expecting to have any shorts because this amplifier worked when I first got it, but I still wanted to check my work before I put it back together again. I put both of the amplifier boards back on the chassis, and then I spent time working on the driver boards. The driver boards are the first part of this amplifier where the signal actually passes through, but it just happens to be the last part of my project. It's kind of funny how that worked out. According to some of the forums, especially Audio Karma, according to some of the technicians who post on there, there was a note that Onkyo included in some of the service manuals that R29 and R31 wattage should be increased to 2 and 3 watts. Now on my model, it already looked like they were 2 and 3 watt resistors. They were quite a bit larger than everything around them, and they also had that pale blue color. I know why that was done, because if these were 2 and 3 watt resistors, you could tell they put off a lot of heat. The bottom of my board was not scorched, but you could definitely tell it's been hot. And also the colored bands around the resistors themselves boiled off a little bit. I elected to take the ultra conservative route, and I actually went to 3 and 5 watt resistors. The nice part about the larger wattage is the leads are thicker and stiffer. That means I can physically mount the resistors farther off the board, so more airspace can help dissipate the heat from around the resistors. And speaking of that, C21 is a little poly capacitor right next to the resistors, and on mine it looked like that resistor was subject to the heat stress from being around that general area, and I elected to replace it just as a precaution. So again, that's R29 and R31, increase the wattage, and C21, just check. If you're working on one, see what type of shape that capacitor is in. Both my capacitors tested okay, but still, it's one of those precautionary things that I like to look for when I'm doing a restoration. And now, with those driver boards back in, I'm ready. It's taken me 2 months, like I said. In that time, I put a new IEC connector in, new speaker terminals. I went through the entire amplifier. I replaced all of the capacitors, including the filter capacitors. I went through the power supplies. I went through each one of the relays in the speaker section and the input section. I went over the protection section and the metering and everything I could possibly do to wrap my brain around how this thing works. And there's nothing else for me to do except try it out. I've probably spent hours over the past couple days checking pictures, comparing it to how I assembled this. Thankfully, most of the amplifier can only go together one way. I labeled all the connectors before I took them off, and like I said, I took a bunch of photos. The only area that I'm a little bit concerned is in the main power supply. There is just such a mess of wires down here that there was no way for me to document each wire with a photo. I probably took like 200 photos of that area, but of course, the couple questions I have, I didn't picture. That's okay. I compared what I built to the schematic, and knock on wood, I'm confident I have it back together again correctly. And now, I'm ready to try it out for the first time. Okay, I've got everything set up just for the initial test. And I have one multimeter measuring the bias for this side. I have my fluke measuring the bias on this side. This way I could watch both at the same time. I've got signal generator and scope connected. I have some test leads connected on the sides here that I'll get into in a later video. For right now, I just want to plug it in, turn it on, check the bias, make sure no smoke comes out, and if the bias is reasonably steady, I'm going to apply some signal to it and see what the output looks like. That's as far as I'm going today. If I get there, that's a win because there's so much that can go wrong. I'm a little nervous, frankly, because of how busy this power supply is, but I'm at the point where I'm ready to go. So it's not plugged in yet. I'm going to plug it in. Actually, I'm going to make sure the power switch is off because I've done that before. That's on. That's off. These are the meter switches. These are in the normal positions. The variable inputs are down. This is for variable in system 1, system 2. So the only switches I'll be operating are the power switch and turning on the set of outputs. Additionally, I have this board wired up just so I could watch the weight monitor, which are these LEDs. And these lights here don't mean much. It's meter position and the which speakers we have on and off. And then there's a light I have taped up here. This is the main power light. And that would normally be behind the power switch, but I just taped it up there for now. Keep it out of the way. All right, double check. Switch is off. I'm ready to plug it in. Here we go. Okay, so far so good. I should do a hot chassis check, but there's no reason to suspect any issues there. I'm ready. I'm going to turn on the switch. I should see that light up. I should hear some clicking. And then I'm going to watch the voltage here on these two meters. I'm actually a little nervous. Here we go. Okay, I see super high bias current over there. Climbing. I see good bias voltage over here on this side. So this side is very high. The weight monitor turned off. I'm going to immediately adjust this bias because I could tell it's too high. Good, and it's coming down in a nice linear motion. Whew, that was a little scary. I only want 20 millivolts. I'm actually going to turn it below 20. I'm going to leave it around 19. This one's at 25 millivolts. I wish it wouldn't be on the volt range. Okay. So we're at 26 millivolts on this side, which is still a little bit high. I am going to take the time to lower this one as well. The manual says this should be 20 millivolts at first startup, and then you check it a couple more times after it's been heated up for a while. I see the weight monitor is still in the middle status. So far, so good. What I'm going to do now is check the other side of the outputs. So this amplifier will actually let you check the bias for the positive and negative cycles of the amplifier. Right now I'm just measuring the positive side. Actually, I don't know if I want to disconnect these while it's on because I don't want to short anything, but I think I can do it. So we take that one off here. Okay. Good. So on this channel, the negative and positive side of the amplifier is biased equally at 20 millivolts. And now I'll do this side. Definitely don't want to short anything at this point. So far I'm having good luck. Knock on wood. Now I haven't really checked signal yet, but good. Excellent. Excellent, excellent. So both sides of the amplifier, the bias is right at 20 millivolts. The positive side of the amplifier and the negative side of the amplifier is biased. It's nice and good. I hate to use the word good, but it's what it is. The weighting monitor, the LEDs are starting to go from the center out, which is what I would want to happen. And I think the next step is I'm going to turn on one of the outputs. And I'm actually going to go to a lower scale. So I have this noise on my scope. I got to track down what's going on. Something's not right on my test bench. So there's a little bit of noise on this right now, but it's just always there. Okay. So now if I turn on speaker 1, this light should light up and those lines better not move. Okay. I got a huge mess of interference here. Again, I think that's my test setup. I really need to get that sorted out. But no voltage, no DC voltage to speak of. Yeah, actually, it's great. Yeah. Okay. And now, I mean, I don't want to get ahead of myself. The bias is creeping up a little bit. Not much. It still seems like we're okay. I'm on a variable input here. So I should be able to put my signal generator on and see if this will actually make a signal. Okay, I'm going to be ready right here to turn this off in case I get a weird oscillation. Good. Oh, excellent. That was one channel. Oh, yeah. Okay. So this is a slow process when I'm doing something like this. It's not even good for me to talk through it because I get distracted, but definitely want to document this. And now, just the smallest amount of a signal, 1,000 hertz. This is a really tiny signal, but it'll tell me if I have any weird oscillations or weird issues. Again, you can't see it in the video, but there's a couple things jumping around in my scope. I have to get that sorted out. I think it might be the way I have my test leads wired. The weighting monitor is coming out a little bit, and now the bias has creeped up. It's about 28 millivolts, and we want it to be 20 millivolts. So I'm going to take this opportunity to adjust it a little bit more. Oh, wait. No, that's because I have a signal on it. And a load. Yeah, so bias, I mean, I just put a little bit of a signal through it. Bias has crept up a little bit. For the purposes of testing right now, I am going to cheat it down a little bit more. And I'm really hoping those problems I was having when I first tested this amplifier can be attributed to this channel being biased super high. I cleaned those bias pots, but I put them back exactly where they were. So even though they probably weren't exactly the same as when I first did my test, they were well within a margin of error. There we are, and now I'm going to bring this down to... It's nice, counterclockwise lowers the voltage. That's always nice, because I've had other amplifiers where it's the opposite, and it just doesn't give you a good feeling. When you know it's high and you want to go lower, you don't want to go clockwise. But it's nice. These bias pots, when adjusting, counterclockwise lowers. Okay, I'm going to put an output back on. All right, that's a little tiny signal. I'm actually going to creep up a little bit on it now and just put out a little bit more wattage. Excellent. I'm going to do that to trigger it. Here's the other channel. Same scale. Excellent. Very good. All right. Boy, am I relieved. Both heat sinks are running much cooler than they were when I first got this. When I first got this amplifier, at this point, these would be like too hot to like touch the actual heatsink, and now there's no issues. I'm gonna let it go for a little bit, and then probably do a little bit more testing tonight, and then hit it again tomorrow. Whew, that was good news. Boy, I'm relieved. I am very happy with how this amplifier is performing. The bias is nice and steady. The output looks okay so far. And everything is tracking well for heat and voltages. Everything is working just like I expected. That's not always the case after one of these projects, so this is a nice find. In the next video, I'll put this amplifier back together again, and I'll verify its performance on my THD meter and go over just some of the finer details about this project and how it all turned out. Thanks for watching this video and the whole series I've made about this amplifier. If you have any questions, let me know, and thanks for watching.